coordinates. Okay, so forces will be in cylindrical coordinates, so you can use F equals ma, where a is in cylindrical coordinates. So I'll do a brief overview and then we'll start solving problems like always. So I said the particle is moving on a curve, and the best way to describe this curve is by an equation such as r equals f of theta. And we've done this before where we said, well, the best way we can describe the motion of the particle is by assuming coordinate frame, which is ur, which is a unit vector in the radial direction, and u theta, which is a unit vector in the tangential direction. So this is 90 degrees. So in order to take this from here and apply it to F equals ma, what we need to do is we need to find forces in the theta direction and find the forces in the F r direction. So once we have those forces, in other words, if you have external forces acting on this particle, let's say gravitational force or spring force, you'll try to resolve it in r and theta direction. That's what I mean by showing an fr and f theta. So this is really the summation. So we can write summation fr is mass times acceleration in the r direction, and you know the formula for acceleration in r direction. It is r double dot minus r theta dot square, and then f theta is mass times acceleration in theta direction, which is mass times r theta double dot plus 2 r dot theta dot. Now what happens sometimes is you can express the forces not in the r and theta direction, but easily in the t and n direction. So what I'm going to do is redraw this. Okay, and show forces in the t and n direction. So the forces in the n direction are, well, let's say this is the force in the n direction. This is the force in the, my bad. So this is tangential. This is normal. So this is ur because this vector is along r, and then this is u theta. My bad, this shouldn't be theta, this should be fn, this should be ft. Okay, so we've resolved forces in the t and n direction. However, we know the curve in r theta frame. So we know r of f of theta. So in this case, again, it's best to use equations of motion in r equals f theta using that frame, so a in cylindrical coordinates. However, we need to now be able to resolve ft and fn along the r and theta direction, right? Because if you do not know how ft and fn is related to fr and f theta, we will not be able to use the first equation. So it turns out that as long as you know the angle made by, so this is un and this is ut, turns out that you can actually find out the angle made by the normal vector un with the radial vector. There is a simple relation, and that simple relation between to find psi is tan of psi equals r, it's in black. So tan of psi equals r divided by dr d theta. Okay, so what you do is you will use the fact that you know r equals f of theta. That is, this thing is given to you. From that, you will find psi using this expression. So once you know psi, you know the angle made by r with n. You also know the angle made by t with theta. It's going to be actually same as previous. It's going to be psi. This is going to also be psi. So then what you can do is you can find the force F. You can resolve the force Ft in the theta direction and the n direction. So theta in the r direction. Similarly, Fn you can resolve in the theta and r direction. So you have the net force in the theta and r direction like shown above, and then you can use that expression to solve for it could be theta double dot r dot. So if that was not very clear, we'll do a problem today which will make it clear. Okay, let's start with solving problems. Okay, so if the arm OA rotates with a constant clockwise angular speed of theta dot equals 1.5 radians per second, so theta dot is 1.5. Determine the force arm OA exerts on the smooth 4-pound cylinder B. So you define the force of interaction between the rod OA with B when theta is 45 degrees. So you're also given theta equals 45 degrees. What about acceleration? Theta double dot. Are you given the acceleration? It's 0. You're given that theta dot is constant, right? So theta double dot is 0. Okay, so that's all I know. And you got to assume that gravity is 0. So this particular setup is not in the vertical plane, but it's in the horizontal plane. Okay, so this thing is like this. So gravity cannot affect the motion of the ball. So first thing to note is that you're asked to find forces, right? And clearly you got to use F equals ma, so kinetics. So you got to draw a free body diagram. So if you want to find the force between B and A, and you're given the mass of B, that suggests that you need to draw a free body diagram of B, which is the ball. So I'm going to draw a free body diagram of B and show all the forces that act on it. So I've removed the ball from the setup. Now to replace the effect of two things. One is the arm OA with a force, and then it also rests against the sledge or the incline, right? So arm OA exerts a force on B, and that force is going to be in which direction? It's going to be always normal to OA, so it's going to be this direction. So I'm going to show that here. And let's call that N. So I'll just be consistent with my notes. I called that N2. Okay, and that force will basically be this way. It's going to be 90 degrees. So other thing happens is that this ball is resting against the vertical, right? And so the vertical is going to exert a force on the ball. And again, that force is going to be normal or normal to the vertical. So there's going to be a force, you draw it here, N1. So the force like this. That's one which I've shown here, N1. Are there any other forces? There's no gravity, right? So that's, it looks like those are the only two forces.
I'm sorry, why? Why is that one?
When you have a ball, right? When you have a ball, like circle, and it's acting on by a vertical wall, the force always passes through the center like that, always, because it makes a point contact, like so.
Oh, I see.
And so the force always passes. Now, if I incline this, still be normal. It always passes through the center of the ball. It's always true. So that I drew N2 normal to line OA, and I drew N1 normal to line the vertical. Okay, now we're going to think about what sort of coordinate frame we should be used. Now it's obvious it's cylindrical coordinates because in this section, but if this problem was not in cylindrical, but if you did not know that, then you can see that you're given R, right? An R given here, which suggests that we should use cylindrical coordinates. So I'm going to try to write this in cylindrical coordinates. So since R is this way, this vector is UR, and since it's turning clockwise, I'm going to assume that this is U theta. So in order to apply equations of motion in this particular coordinate frame, I need to resolve N1 and N2 in the direction of R and direction of theta. So I need to find the angle made by N2 with R and theta, and also N1 with R and theta. What's that? So this is this theta? That's theta, right? Just from geometry. This angle here is going to be theta. Okay, I also need to find the angle made by N2 with either the vertical or the horizontal. So if I drop this down, this is theta, this is 90 minus theta, so this should be theta. Right, because N2 is normal to N2 and UR are at right angles to each other. So now I can start writing the equations of motion. Okay, it's good to think about what I'm interested in. Well, I'm interested in N2. I'm going to find the force arm OA exerts in the smooth 4LB cylinder. Right, that's N2. So I'm interested in finding N2. So the net force in the R direction, in this direction, is going to be N1 cosine theta. So it's this force. I take N1 and I've got to resolve it along the R direction, this direction. And then N2 needs to be resolved in the direction of R. So it's going to be N2 sine theta. So this way. Is that right? No. That's not right. N2 is normal, so the component is going to be 0. That doesn't make sense. So it's just N1 cosine theta, right? N2 is 90 degrees to, this is 90 degrees, right? So N2 is, there's no component of N2 in the UR direction. It's going to be 0. So just n1 cosine theta. So n1 cosine theta is mass times r double dot minus r theta dot square. Then I need to do f theta, so all forces in the theta direction. So now I have n2, which is acting only in the theta direction, and then I need to resolve n1 in the theta direction. So that's going to be n1 sine theta. So this is n1. I have to resolve it this way and this way. So this component I already wrote as cosine theta. This component is n1 sine theta, and you can see it acts in the direction which is in the negative theta direction. So that's going to be minus n1 sine theta equals mass times acceleration in the theta direction. So that is this. Okay, so n1 is unknown, n2 is unknown. I know theta double dot. I don't quite know r double dot and r dot. So I need to find r double dot and r dot by using the geometry there. So can I find relation between r and theta? Can I find the curve r equals f of theta? So this is the curve along which the ball will move. The ball moves in a vertical line, right? So r is this. I've been told that this is constant. So r equals so this distance is r cosine theta, right? Because r is this. This is 90 degrees. So that's the hypotenuse. And then I can resolve that in the theta direction. So that is equal to 4, which is a constant. So this gives me r equals 4 secant of theta. 1 over 1 divided by cosine is secant. Then I need to find r dot. So I need to find the derivative of secant, that is secant theta, I think tan theta. Is that right? Yeah. Okay. So at theta equals 45 degrees, if I put theta equals 45 and theta dot is 1.5, I get 8.485. Then I need to find the second derivative of this. So 4 is constant. Okay, so when I do this, I normally do it this way. I treat tan theta and theta dot as a constant, take the derivative of secant only. So I get secant theta tan theta, and the other two terms are constant. Sorry, my bad, I skipped one term. It's going to be secant theta tan. So derivative of this itself is that times tan theta theta dot. Then I keep the secant constant, and I take the derivative of tan theta. That's going to be, so what's the derivative of tan theta? Is secant square. And then take derivative of theta, so it's going to be theta dot times theta dot. This theta dot is same thing here. And then finally I keep secant and tan theta as it is, and then take the derivative of tan theta double dot. So I get this expression. I'm going to rewrite this slightly to move things around. So 4 secant theta tan theta, those two terms remain constant, and then I need to take the derivative of theta, which is theta double dot. So again, this is 0. This is given. Theta is given, so I can actually find what happens at theta is 45 degrees. It's basically 38.18 feet per second square. Okay, so I know r double dot, I know r dot now from here. So putting r dot, r double dot, theta double dot in, let me call this 1 and 2, and solving for n1 and n2 gives okay, this is the thing I'm after. This is the answer. So again, so once I found r, r dot, r double dot, and substituting equations 1 and 2, I have two equations, 1 and 2, and two unknowns, n1 and n2. I can solve for n1 and n2 using those two equations. I skipped a lot of steps. I skipped the math, that is the numerical part. I just put out the equations. So you got to check this to get it right, check this to get it right. Any questions?
Besides for video in this chapter, what will you exactly, what coordinate system you use?
Yeah, so it really depends, right? I mean, the hint you'll get is we'll give you the curve r, we'll show an r, or we'll have r equals f of theta, could be cosine. We'll explicitly give it to you. In this case, it's not explicitly given. You got to infer that r equals 4 secant theta, but sort of that gives you a guess. You can guess it's going to be in cylindrical coordinates. So I said the hardest part is not now. When you know this is coming from 13.6, you got to use cylindrical coordinates. When you are answering this in an exam or final exam, you have a problem thrown right there. You got to figure out first if it's a kinetics problem, and then you got to figure out if it's cylindrical, rectangular, or tangential normal. So that's where it gets harder. It's easy now because you know what to apply. In the exam, you'll have to figure that out. Unless you figure it out, you cannot solve it.
But in this case, R is always a function of data, right?
Yeah, yeah. That's right, that's right. Now what I'm saying is, we are doing a section on cylindrical coordinates. So the questions are all on cylindrical coordinates. In the exam, you see a problem, but we will not tell you this is to be solved in cylindrical coordinates. You got to figure that out. And the hint you get is, if you look at this problem, I showed an r over there. So that gives you a hint that perhaps the cylindrical coordinates is the best way to solve this. This can be also solved in rectangular coordinates. It can also be solved in normal tangential coordinates. It's going to be more work. It's less work in this coordinate frame. Okay, all these problems can be solved in any frame. Okay, your answer doesn't depend on which frame you solve it, but this frame, it's much easier to solve the problem. Okay, so the collar has a mass of 2 kgs. And travels along a smooth horizontal rod defined by r equals f of theta. So the good news is that you're given the curve. So that's indication that cylindrical coordinates is the way to go. Where theta is in radians. Determine the tangential force. So we got to find Ft and normal force Fn acting on the collar when theta is 45 degrees. So theta is 45 degrees. If the force F maintains a constant angular motion, theta dot equals 2, which means that theta double dot is 0 because it's constant speed motion. So you're given forces, you're told to find, you're told to find forces, right? So clearly this involves equations of motion, so free body diagram. The only thing you're given the mass of is that collar, so I'm going to draw a free body diagram of the collar and not of the rod. You're given r and theta, so it makes sense for me to show that coordinate frame, fr and f theta. So this is going to be u r and u theta. However, you're told to find the forces in the tangential and normal coordinates. So I'm going to draw a tangent. This is going to be a tangent, and this is going to be the normal. So un and ut. I need to find the forces in the t direction and forces in the n direction. So it's sort of a mixture. The forces asked in the tangential normal frame, but you're given the curve. The motion is described in r equals f of theta coordinate frame. So here is an example of what I talked about a little while back, which is if you're given r of f of theta, but you're told to find forces in t and n, then there's a way you can resolve forces. You can find forces from the r to the n frame by finding this angle phi, or psi, psi. Psi is the angle between r and n, and tan of psi is r times dr d theta. So we can find psi because we know what r is. It's just e of theta. So I can find psi. Once I find psi, I can then resolve forces in the p and n, the r and theta direction. So, by the way, my free body diagram is not complete. I'm shown an F, so I need to draw the F. And since this collar is sliding on a rod, that rod is going to exert a force which is in the normal direction, right? And that the force always passes through the instantaneous center of this curve. So this curve has a center somewhere here, and that center keeps changing. Right? Remember we talked about radius of curvature. So radius of curvature is this. There is a radius and associated center. For a circle, the center remains constant, fixed. But in this case, when it's a curve, a weird curve like this, with the center over here, which keeps changing as this car moves. Right? Radius of curvature keeps changing. So at this point, at this instant, the center is somewhere here. So then there's going to be a normal force like this. It's in the un direction. Okay, so given that, we can write the equations of motion. Again, we want to write equations in the r theta frame or the cylindrical frame. So I need to find the net force in the r direction, where this is the r direction. So I need to resolve n in the r direction and f in the r direction. So n cosine of psi is acting in the positive r direction. And I have to resolve f again in the psi direction. So you can see that this angle here is also psi, because this angle here is going to be 90 minus psi. So n cosine phi psi f. If I resolve f in the psi direction, I get f sine of psi, and that's going to be positive because this force is, well, it's going to be this component f cosine psi equals mass times acceleration. So mass times r double dot minus r theta dot square, and then f of theta is going to be, find the force n in the theta direction. So it's going to be n sine of psi. So it's going to be this way. It's going to be negative. And then f I need to resolve in this direction. So it's going to be f cosine psi, and it's going to be positive, equals mass times r theta double dot plus 2r dot theta dot. Okay, so r is e of theta, r dot is going to be e times theta, and I need to take the derivative of theta, so theta dot, and then r double dot is going to be, when I take the derivative of those two terms, I keep e theta as a constant. So let's first take the derivative of e theta. That's going to be e theta theta dot, and then theta dot here was kept a constant. Then I keep e theta as a constant and take the derivative of the second term, which is theta double dot. Turns out that theta double dot is 0. So all I'm left with is this. We can sub in theta dot equals 2, theta dot double dot equals 0, theta equals 45 degrees. And you can also solve for psi, you get 45 degrees too. So psi came from here. Okay, how did I get psi? Well, I know r, and I know r d theta, so I can solve for psi. Yes, I'm not sure if this is there on the formula sheet. I can check, but these expressions would be on the formula sheet. Okay, so I'm going to skip a lot of steps. That is basically the numerics of this. Solving for f and n from 1 and 2 gives. So I said I'm skipping a lot of steps because what I did was I put in the value for mass, I put in the value for r double dot, and so on. I got two equations, 1 and 2, and I had two unknowns, f and n, and it's basically a problem in linear algebra. Pretty sure you're good at solving those, so I'm going to skip that. F equals, it turns out that you get F equals 24.8 newtons, and you get N equals minus 24.8 newtons. The sign there for N shows that the assumed direction of N was opposite to what it really is. So N is not pointing, I assumed it to be pointing outwards, but N is actually pointing inwards. Okay? We still have 6 minutes to go. I'm hoping to get started with the last problem, and I won't be able to finish it. So here's another problem which is probably looks slightly more daunting than the first one, the second one. So rod OA rotates counterclockwise at a constant angular speed of theta dot. So theta dot is 4. Since it's constant speed, theta double dot is 0. The double collar B is pin connected together such that one collar slides over the rotating rod and the other collar slides along the circular rod described by the equation r equals 1.6 cosine theta. Okay, so what's happening is one of those collars slides along OA and the other one slides along the circular rod. If both collars have a mass of 0.5 kilograms, determine the force which the circular rod exerts on one of the collars and the force that OA exerts on the other collar at the instant when theta is 45 degrees. So theta is 45 degrees. You're going to find the forces of interaction between the two collars and rod OA and and the circular rod. Okay, so you're given r as a function of theta, You're told to find forces. It's a kinetics problem. You got to draw free body diagram. Now, since you're given the mass of the two collars combined, right? Both collars have a mass. I would draw a free body diagram of both the mass because that's how I can write F equals ma. So, a free body diagram of both collars would be something like this. Okay, so again, the way you think about the forces is rod O, the collar B in this case slides along OA. So there's going to be a force of interaction between OA and the collar, and this force is always, remember now, the force of interaction is always normal. So it's going to be normal to the two. So let me call that NB. Similarly, the other collar, C, it slides along the circular rod. So the force, again, is going to be normal to the surface. In this case, the surface is a circular rod. So the normal to the circumference of a circle is always, it always passes through the center of the circle, right? So this will always pass through, let's call this O, it always passes through O. Passes through center of circle. Okay, and you're given that this is R. Sorry, that's not R, my bad. R is this. Let me call this O1 because there's already an O. Let's call this O1. This is O. Okay, so cylindrical coordinates, I need to establish the coordinate frame. In this case, the coordinate frame is going to be along UR and U theta. This is UR. So next thing is to write the equations of motion. So NB is in the theta direction, so I just write the equation first in the theta direction. NB summation f of theta is NB, and then there's NC, and that NC acts along by an angle. Well, I don't know this angle, sorry about that. This is theta. I got to find the angle made by NC with UR. So, okay, my bad. This, I should write this as theta, right? This is theta as given here. So this is theta. So it's going to be NB is acting in theta direction, and then NC. Okay, give me like just a minute. It's already 9:50. I'm just going to set up the equation and let you go. Okay. NB is acting in the theta direction. NC is acting at an angle theta, so I need to resolve it in the theta direction. So it's going to be NC sine of theta. Okay, and since it acts this way, it's going to be positive, equals mass times R theta double dot plus 2R dot theta dot. Similarly, I need to write FR, which is all the forces in this direction. So the force in that direction is going to be NC cosine of theta equals mass times R double dot minus R theta dot square. So that's it. I have to find NB and NC. I'm given that R equals 1.6 cosine theta. So from that I can find R dot, R double dot, theta double dot is given. So basically I can know everything on the right hand side. The only two unknowns are NB and NC. It's two equations for two unknowns, and I can solve the two unknowns. So I'll complete this later and post